What you're looking at right now is called the unit circle. Okay, so this is going to be our focus for today, is trying to understand what all of this means, because I know it might be a little bit overwhelming looking at this. So we're going to learn how to use this to quickly and easily calculate certain trig functions without having to use a calculator. Okay, so the goal, we're not using a calculator, we're just going to use the unit circle to calculate values for trig functions. First, let's look a little bit closer at the structure of the unit circle. So the unit circle is just a circle with a radius of 1. Okay, and the center of it is right on the origin of the Cartesian coordinate plane. So let's say we were looking at the circle, the unit circle. Every point here, these 4 points are lying on the circle, so all of these points, and we can see that it shows that this has a radius of 1. Let's say we were to put a triangle in quadrant 1, the first quadrant. And the triangle, one point of it here lies right on the circle. Okay, so we have some coordinate point here that is on the circle. What would the hypotenuse of this right triangle be? Okay, well, it would definitely be the radius of this circle, and as we just looked at, the radius is a length of 1. Okay, so the radius of the circle, which is the hypotenuse of the triangle, is a length of 1. Okay, if we were going to look at the legs, this side here that's laying along the x-axis, so that's going horizontally, we would think of as x, some value x, I don't know right now, and this would be some value y. Okay, so we can think of this coordinate point here as being this x value, so we go this way to the right and then up, and we're at this coordinate point. Okay, so if we were working with this triangle, what would the trig functions be for this angle theta? Okay, so sine would be opposite over hypotenuse, so that's y over 1. Cosine would be adjacent over hypotenuse, and tangent would be opposite over adjacent. Okay, then we have all of our reciprocal trig functions, which are just the same thing but flipped around. So 1 over y, 1 over x, and x over y. So the really cool thing about the unit circle is that when we create a triangle inside of it, okay, notice that I really don't need this 1 underneath my output here. Like if I just have a y, that's the same thing as y over 1, okay? So I can get rid of both of these 1's in the denominator, and now I can see that, well, if I wanted to find sine of this angle, that's just y. Like it's just whatever this coordinate is right here, okay? So if I want to calculate this without using a calculator, I just simply look right here at my coordinate point, and that's the answer, okay? That is what the output is, okay? Oops, hold on. And then similarly, if I wanted to find the cosine without using a calculator, the cosine value, the output, is just the x. Whatever is right here for this coordinate point, that's my cosine, okay? Tangent, I would just take those two values I see for that coordinate point and put y divided by x, okay? So before we start actually calculating values with the unit circle, I want to show you some of the kind of the crazy looking stuff on here. Like, why do we have these specific coordinate points on the unit circle? Like, we know why we have these 4 here right now, okay? Because the circle is has a radius of 1, so it makes sense that it hits all of those 4 points. But why are these 3 points in each of the quadrants? Okay. Actually, this is going to come back to something you learned in geometry, so special right triangles, if you remember those. And if not, that's okay. So this is just to refresh your memory. So one of the special right triangles was a 30, 60, 90 triangle. So 30, 60, 90. And then if you remember, there was a specific ratio that all of the sides had with one another. So the side that was opposite the 30-degree angle, that had a ratio of 1, hypotenuse was 2, and across from the 60, that was square root of 3, okay? So 1, 2, square root of 3. If I was actually to take this special right triangle and put that triangle on the unit circle, okay, let's put it on the circle, it would fall right here like this, okay, right where this triangle is. Well, the thing is, we can't put this triangle on the unit circle yet, because if you look at the hypotenuse, it should be 1 because the circle has a radius of 1. So I need to change this 2 so that it scaled down to a 1. Okay, so how would I do that? So if I take this 2 and then simply just divide that by 2, now it's scaled down to 1. But if I'm doing that, I have to do that to all the other sides of the triangle as well. So every side of the triangle, I divide by 2, and then now I can fit this onto the unit circle, okay, because this would be a length of 1. So here would be the hypotenuse, it's a length of 1. This side of the triangle would be 1/2, and then this side of the triangle would be square root of 3 over 2, okay? So now I have that special right triangle on the unit circle. What would this coordinate point be? Okay, what would this point be? Well, it would simply be the x, okay? How far the triangle goes in this direction, so the x, so square root of 3 divided by 2, and then the y, 1/2, okay? Just like we saw here, it would just be the x and the y, okay? So that's where we get our first coordinate point from the unit circle. Then, if you remember the other type of special right triangle, there was the 45, 45, 90 triangle. So the ratio for this was 1, 1, square root of 2. Okay, so this is definitely not going to fit on the unit circle right now unless I change this hypotenuse to a length of 1. So to do that, I have to divide this by the square root of 2. Okay, then that will be 1. Then I'll have to go and do the same thing for the other two sides. So what do I get then if I do that for all sides? Well, this one, I get 1, just like I wanted to. And then if I rationalize the denominator, like we've been practicing, this would turn into square root of 2 over 2. And that's what we get for both of those sides, okay? So now if we put that triangle, so that would be this middle line here, if we put that triangle on the unit circle, this would be a length of 1, square root of 2 over 2 on both of those sides. So that means the coordinate point here would be square root of 2 divided by 2 over square root of 2 divided by 2. Okay? And then the very last triangle we're going to put on is actually another 30, 60, 90 triangle, but oriented the other way, so that the 60 is here, and then the 30 is here. Okay? So that means this side would be 1, 2, square root of 3, and if we're doing the same thing like we did here, if we're dividing all the sides by 2, what then do you think this coordinate point will be without me drawing this on here? What will this coordinate point be? Well, it should be 1/2, because that's in the x direction, 1/2, comma, root 3 divided by 2. Okay, so now we get those 3 coordinate points that are in the middle of our unit circle. So if we go back to the unit circle, okay, we can see those coordinate points laying there. So that these are made from those special right triangles that you learned about in geometry. And then if you look at each of the quadrants, they're not altogether too different. They are all coming from the special right triangles, but then depending on the quadrant that they're in, the sign just changes. And this is what we looked at yesterday, right? Like depending on the quadrant, your sine or cosine may be negative or positive, okay? So here, if we remember from yesterday, all of them are positive, okay? All students take calculus. Okay, so here all of them are positive. Here, just the sine values are positive. And so if you remember, sine corresponded to our y value. So that means all the numbers that are in the y spot should be the only ones that are positive here, okay? So that's what we see. All of these are positive new, okay? And then calculus, that stands for cosine. So now all the x ones are positive, okay? And then tangent, well, this is a little weird because tangent, if you remember from what we just looked at, tangent is going to be y divided by x, okay? So that does make sense, because if I take y divided by x and negative divided by negative, that gives me a positive, okay? So that's where we're getting all of the coordinate points in this unit circle from. Okay. Other than that, really the only other thing here that we're seeing is we have each of the angles. So like this 30-degree angle here, instead of it being down here in this corner, it's just placed over here by the coordinate points, okay? And then its corresponding angle measure in radians is also shown, okay? Which is really nice, so we can see easily what each degree converts to as a radian. So 30 degrees is a radian, is just pi over 6, okay? Or we can easily use it the other way around. We can convert radians to degrees, so that's really helpful here. All right, now let's start actually using this to calculate some values here. So as we just looked at in the unit circle, sine is going to correspond, if you remember, sine is going to correspond to the y coordinate. To the y coordinate. While cosine corresponds to the x coordinate. So you can look over here, cosine is going to correspond to x, sine is going to correspond to y. Okay? So let's use our unit circle to figure out what sine of 135 degrees is, but without using a calculator, okay? So that means I'm going to just go to the unit circle, find 135 degrees, which is right there, okay? And then I'm going to remember that cosine is my x value, sine is my y value. So if I want to find the sine, that is just the value that I see in the y spot. So my answer is square root of 2 divided by 2. Okay, and we can verify this with a calculator, and it is definitely correct. Okay, so the unit circle is just another way to quickly and easily find that answer. Okay, here's another one, but now it's in radian. So I'm going to go to the unit circle and find 7 pi divided by 6. So 7 pi divided by 6, that would be right here. And I want the cosine. So the cosine would be my x coordinate. So that would be this value right here. So my answer should be negative root 3 divided by 2. Okay, I'm going to encourage you to stop the video if you can and see if you can find the other values here before I go on and find them myself, okay? So the next one is a little weird because I have cosine of 3 pi, but maybe if you pause the video here and you looked, there's no place where I see 3 pi on the unit circle. So what's happening here, okay? Like I have pi, I have 2 pi. How do I find 3 pi? So to do that, we're actually going to think about radians as like slices of this unit circle, right? So if I was counting by pi over 2, okay? So pi over 2 on the unit circle, that's 90 degrees. It's located right there. If I count another section of pi over 2, that gets me to pi, right? Then I get 3 pi over 2. It's just kind of like counting fractions, right? Like I have 1/2, 2 halves, which makes 1, 3 halves, 4 halves, which makes 2. All right, so I can keep counting, and I'll finally get up to 3 pi. So 5 halves and 6 halves. There we go, 3 pi, okay? So 6 halves gives me 3 pi. That's right here on the unit circle. So back up a little bit. I can just keep counting this way, and I land right there at -1, 0. Okay. So at this coordinate point, this is where 3 pi is if I rotate past just the values I see here on the unit circle. Okay. And if I recall, we wanted the cosine of 3 pi. So the cosine would just be that -1 that's there, the x value. Okay, and then we can do this as well with angles. So 390 degrees, like we practiced a little while ago with finding angles that are more than 360. So let me erase these. Okay, so we know that this is 360, so 390 would be if we go 30 more degrees, so 390 would be right here. Okay, so this would be 390 degrees. So if I'm finding the sine of this, the sine is the y value at that coordinate point, so the sine would be 1/2. All right, cosine of 5 pi over 3. Thankfully, we can see this pretty easily on the unit circle. So 5 pi over 3 would be right here. And we were finding the cosine, so that's the x value at this point. So that would be 1/2. And then the very last one is tangent. So if you remember me talking about before, tangent is just my y value, my y coordinate, divided by x. Okay, so at 210 degrees, so where is that on the unit circle? So right here, I am simply taking my y value, which is -1/2, and dividing that by my x value, so -√3 divided by 2. All right, so now let's go ahead and simplify this. So if I use a strategy from, I think it's last semester that we had this, if we have a fraction divided by another fraction, so we have nested fractions, we can take the fraction in the denominator, so we can take this one and flip it and multiply. So I'm going to take this, flip it upside down, still negative, and multiply it by the fraction on the top. So it's no longer here anymore. I moved it up and I flipped it and multiplied it. So if I do this, the 2's will cancel out, and a negative times a negative is a positive, so then I'll have 1. So 1 times √3. If I rationalize the denominator, that gives me √3 over 3. Okay, so that would be my answers. That's my tangent value, √3 divided by 3.